Good afternoon, ladies and gentlemen. Welcome to the Star Talk of the New Generation Star Project. I'm Yixing from Jilin University, China, and it's my great honor to be the host for today's talk. Our conversation will center around the theme of exploring new frontiers in robot autonomy empowered by foundation models. First, let me introduce our distinguished guests. They are Professor Fei Gao from Zhejiang University, Professor Boyu Zhou from Yat-sen University, Professor Diego Paez from ETH Zurich, and Professor Liang from Oxford University. Welcome. Before we begin our conversation, I'd like to express our gratitude to NOKOV Motion Capture for providing this opportunity for academic exchange among new generation of researchers. So first, I have a question for all of you. If you have used foundation models in your research, please raise your left hand. If not, raise your right hand. So Professor Gao, you haven't used foundation models?
Yes, I haven't, not yet. Okay, I haven't used foundation model in my research, and because I think mainly because that I'm more like a traditional guy, and also my research area is in the motion planning and autonomous navigation, and also the swarm coordination of microframe robots. And so I think in that area, most of the mathematical problem can be explicitly modeled, and so we mainly use some geometric modeling method and some numerical optimization to solve this problem. And so at our current stage, our main research focus on these traditional ways to make the flying robot flies more faster and more intelligent. And also, I think in a very soon future, we make one step further because currently we are doing the research on the motion of the robots, but in the future, we will try to move forward to the cognition of the robots. So I think at that time, we will try to use some, and certainly we will try to cooperate with some foundation model to let the robots can better know this world and better do the decision making.
Yeah, thank you for sharing. And also because I know you are expert in aerial robots, and from your video, we can see those are quite small aerial robots. So I know foundation models also require a very expensive computation cost. So that may be one of the concern, I guess. Okay, yeah, thank you. And then Professor Zhou, could you share with us some of your experiences with using foundation models in your research, please?
Yeah, thank you. Actually, I also study mobile robot, aerial robot. We do very similar research with Professor Gao, but recently we do something about 3D reconstruction. And in this area, one of our goal is to create a big data set that contain many 3D model of buildings or architectural structures. So when we build this data set, we find that we have to, one challenge we face is that when we obtain some urban scale data, we would like to segment this large scale data into individual buildings. And this process, we want it to be automatic, because if we do it manually, it will take many times. So here we use a foundation model to do the segmentation. First of all, we use SAM, the segment anything model, to first segment the bird eye view image of the 3D data. So the original data is about like a city scale. It contains many buildings, but after the segmentation, each individual building will become a single cluster, a distinct cluster. That's what we did when we use the SAM model. But however, this cluster may contain something except for the building, like trees, river, or road. They are not building. We want to remove them. So we use another foundation model named CLIP, the contrastive learning language image pre-training model. And so we can use it to evaluate whether the cluster belong to building or not. And so we can automatically remove those non-building subjects. And that's what we did in our research. Actually not some algorithm on robotics, but we do it use for data set creation. Yeah.
I see. So you also deploy the foundation model on your area robot?
No. We use it to do some offline processing of data.
Oh,
Yeah.
okay. And after that, so what's the downstream task?
We can use this data set to train some models like perception model, prediction model, so we can better perceive the environment using aerial robots.
Okay, so this robot, do you mean the area in the area robot?
Yeah.
So, is it easy or is it straightforward to deploy the foundation model on your area robot?
No, actually we didn't deploy the foundation model on aerial robot because the processing unit is very tight in the aerial robots. We did use the foundation model before we training the algorithm. We do some pre-processings. Yes, and so after we obtain the data, we train a much smaller model, and that can be used for aerial robots.
Okay. Yeah, thank you for sharing. Yeah, and also Professor Paez, could you share with us some of your experiences with using foundation models?
Sure, thank you so much. Thanks for the invitation. I'm glad to be here. So in our group, we work mostly with healthcare data. We work with human modeling and modeling what the person does in different diseases. So with people with spinal cord injury, people with Parkinson, people with stroke, and elderly people. And at the moment, we are very interested in classifying what the person is doing at any moment. So very similar to motion capture. What you do with the motion capture system, you try to segment motions. In this realm, we try to use some of the, I think it's called time GPT, where you try to use time series segmentation. And it's where we are exploring using foundation models. Is the first application where we started, and just a couple of students are working on that. And it's complex because usually you don't have the data sets large enough in the healthcare domain to be able to deploy these models. The retraining of these models also require you to have very clean data. And at the end, it makes it quite complex for translation. So the first task that we execute is simply classification of motion primitives. So what the person is doing. And in there, I do see potential because you can have a very good classification, segmentation of the time series, which is not a critical task for the healthcare that is mainly our research. Still, for the main research in our group, it's very difficult. Like we want to predict disease onset. We want to deploy emergency situations. We want to be able to know if the person has a high blood pressure episode. In these cases, we need to have a model that we can explain. We need to have a model that we know that the data is used inside the model. It is very clearly transparent for the clinical application. So it makes it quite difficult yet to deploy something like a foundation model. But I see the potential for the future.
Okay, I see. So for example, the classification results comparing with traditional or commonly deep learning methods, what are the advantages do you think that foundation models have?
The main advantage that we have is that we don't need such a large data set to start with, especially when we have pathological situations. Like in motions, I mean, if you are a healthy individual, your motions are very descriptive, are very clear, and there are a lot of open data sets that you can use. But when you go to a pathology, person trying to drink something, a person using the phone, a person sitting or transferring from the seat to a wheelchair, those data sets don't exist with a pathology. So, but being able to segment these quite easily using a foundation model, it allows us with a very simple small data set to do transfer learning.
Okay, I see. Yeah, thank you for sharing. And Professor He, how do you utilize foundation models in your own research work?
So first, thank you, NOKOV, for the invitation and the organizing of the event. first. Thank you, Yixing, for the hosting of the event and the questions. My work is in wearable robotics, software robotics. I lead my lab in healthcare biorobotics, where I have a major objective is to developing those technologies or AI solutions for people to recover faster, reduce the likelihood of injuries, providing better well-being from an overall rounded perspective. Can you hear me now? Foundation model has been quite new for me. There are two things I'm trying to explore within my lab. The first thing is to developing AI co-pilot for training, regulating the actions, assisting the operations. This can be reflected in the training of medical professionals, the improving the efficiency of learning, training athletes, as well as recovering, facilitating doctors as a co-shared autonomy. This is, I firmly believe, AI and a human are actually designed differently. Computers can do things like difficult for human to do, and vice versa for human, we are able to create something that's beyond the design features of AI. So if we're able to developing those co-pilot type of agents that working together with human in performing certain tasks, regulating the actions, we're able to synergize the features and advantages from both parties, and then probably creating a better world for enhancing our performance, recovering, reduce the injuries. The second stream of line of research we're trying to exploring within foundation model is more on the word models to understand the physics of movement. Many of the current commercially available foundation models are large language models, which are mainly extractions on the probabilistics of text. So the generability of those models in predicting or understanding the real world interactions, the physics of how human or any agent interacting with the world has been quite limited. And that's also sort of beyond the capability of the text to understanding or training those large network that can understanding the meanings to extract the reasons of actions. So we're trying to utilizing human data on the movement, which also part of the work working with the NOKOV technologies to extracting vision data to understanding the kinematics of human movement. This both in the operational side with clinics as well as athletes doing sports, also converting the injury videos from athletes to understanding the likelihood of any physical action that can lead to abnormality of the human systems. And by building this word model, I hope we could combine this with the co-pilot, which are more likely the language-based model as the interface to better building an interface between assistive robot and a human. So yeah, that's mine.
Okay, so as I can see that you would like to integrate foundation model as a module into your complete robotic system. Or is there any planning on designing any novel mechanisms together with foundation models, or you just mainly plan to integrate the foundation models and use use it as for the interactive functionality between the human and the robot?
Well, the first thing is like we don't really have the true foundation models at this moment. Most of the models, especially the language models, are not capable of dealing with interactive tasks. And intelligence sort of like emerging through the interaction with the environment. How baby learn from the interactions, how our eye as a sensor to capture the information of imaging, how us utilizing the tactile information through our hand to understanding the property of the object, they all forming a sort of like physics of word models, which are currently neglected by those language-based models. So my objective is utilizing movement data to building physics through the human muscle-skeleton systems, the kinematics in the joint, the actions, to facilitate understanding a large model that better understanding how human can interact with the environment.
Okay, I see. Yeah, thank you for sharing. And Professor Paez, I also have a question for you. So just now you actually mentioned the data issue. So as we know that utilizing foundation models in the field of robotics may also face some challenges. One is the data scarcity problem. So you also mentioned, especially in your field, data may also be an issue. So usually, how do you tackle this kind of challenges?
Yeah, that's a very good question. That's actually in the whole healthcare domain. It's one of the most challenging problems because we as humans, we seem very, very different when you look into your biosignal data. Each person is quite unique, and generalization of models in healthcare is highly regulated because it's a medical application. So you always have a lot of regulations into what is generalized and what is not. So we always required a huge effort to capture this data. I believe there is no clear solution yet to this problem, but rather we have to be very careful in our intentions of creating datasets, the specific datasets that we need that give us the information required to construct generalized models. So in robotics, I feel is the same. Robotics has the ability yet to use dynamics or physics-based simulations that allow us to do a lot of interactions. But when you put, for example, humans in the loop, there is where everything crashes. It will not work because we don't have yet a simulation of the human, a simulation that is actually valid or sufficient. There, when it comes at the normal of traditional models of control, traditional control is much more effective because it can interact much better with the changes in the real world, especially with humans. But we have seen a lot of improvements in the simulations that allows, and also in learning policies that allows the robots to interact and create models that are more effective. So to not make it too long, in my view, we need to create these data sets to be very meaningful. And that the potential is there. If we have a very good representation of a latency space that is learned from a foundation model, and we have our own small data set for the application we want at hand, we have a potential to join them. However, we also risk a lot that our data is so small and so specialized that we are just overfitting it and it's not really generalizing. So this is a big problem of applying foundation models to any small use cases that we build, either in robotics or in healthcare. There's a lot of questions and a lot of research to be done there.
Yeah, I see.
Can I just follow up on the questions on data set? From my understanding, obviously the optimum goal is we having an agent able to quickly learn through environment, just like what human does. We can extracting all sorts of information and train this super powerful foundation model that can understanding the reasons of any action to do objective-based tasks. But before we get into that stage to fully understand how brain works or having a super powerful agents that are able to interact in the real world, we always struggling to finding the trade-off of what type of data we need to train. Are we supposed to have excessive amount of data that we capture all of the data, replacing as many sensors as we can to collecting as many data as we can, or we supposed to target or specialize the regions of data to extract the most meaningful data source to better train a data synthesized for this particular interaction. So at certain point, well, different model of data will come from different features. From the vision perspective, probably at a certain point we end up to the stage like we have too many data. We have excessive amount of data, and not all of them are useful. And we have a really large models which not able to, in the medical field, we're probably trying to understand how to design a particular sensor mechanism or data collection protocol to find the best type of data we need and the exactly amount of data that fitted our model. Not only excessive, but also not overfitting the data. Yeah.
I see. Yeah, thank you for sharing your opinions. So actually, both of you mentioned that the scale of the data may be small, especially in your fields. And also just now, Professor Zhou, you also mentioned that later on you would like to combine both large models and small models together in your work. So how do you think combining these foundation models and small models together would work in robotics?
Okay. Actually, I think these two kinds of model are suitable for different tasks. Because when we use mobile robot, most of the time we require real-time performance, and so actually it's not very possible if we fully do the computation on board. Except for we use a external server, something like that. So I think actually a foundation model is good for do some data pre-processing. Like before we create some algorithm, we can use it to do some basic work. And then this work must be transferred to some smaller model that can be used on some like very power limited, computationally limited device. Yeah.
Yeah, thank you. And Professor Gao, so have you also faced the issues with data? Is there enough data in your research work? Or what kind of specific challenges do you usually tackle in your area, Robert?
Okay, I think actually most of my research not data-driven works. We just do some mathematical modeling, use some geometric way to best mathematically model this world, and also to model to get some formalized model for the UAV's locomotion and collision avoidance. So, but I still think that in the future the importance of data will play more and more important. Will have more and more importance because there are many aspects of this work that that may not be easily modeled by math. So at that time, we may need some neuralized method to use some network to model to get some big model to get some foundation model, and also with actually it may need enough data to get there.
Thank you for sharing. And now let's come to our interactive session. So for our audience, both here and joining us remotely, if you have any questions that you would like to ask, please raise your hands. As a reward, we have prepared some little gifts generously offered by the NOKOV company.
My main research is on the aerial robot. So I have a question that in aerial robot, there are two main there are two main approach about the data-driven planning or the AI-based motion planning. So I want to ask that do you think the AI-based motion planning will be an important way to improve the motion planning level?
I basically get your question is that will the reinforcement learning based method be a mainstream way to do the motion planning for UAV, right? In my opinion, I think RL has huge potential. And for example, if we do some planning modeling for some specific robots, sometimes we will get a very good mathematical model, but sometimes we cannot, because not all the objective of a planning problem can be explicitly modeling in math and in some equations. And also, in current autonomous navigation framework of quadrilaterals, and also for any mobile robots, we always do the module by module, the block by block way to do the modeling. For example, we do the we have the SLAM block, we have the planning block, we have the mapping perception module, and then we stack all these sub-modules together. But in this way, the cost and also the gradient of each part of the block cannot flow to each other, which means these blocks are all independent in mobile robot systems. So in this way, I think the bottleneck will exist because we cannot get make an end-to-end, a truly end-to-end optimization of the whole system. So as a conclusion, I think traditional motion planning method, soon or later we will come to one stage that we have to combine this optimization-based method with reinforcement learning, because we have to do the end-to-end optimization. We have to break through this bottleneck to get more agile, more intelligent, and also more smart flight, and also another locomotion performance for all of these robots. Okay, that's my opinion.
Yeah, thank you. Any other question?
So maybe I have something to say. I think actually many of my research follow the traditional method like mathematical modeling and then dynamic model and design optimization method to solve the problem. But recently I have a feeling that when we come to a new application or new problem, we have to design a new math formulation, and then we have to write hundreds of, or even thousands of lines of code. That's very tedious actually, because the code we used before cannot be easily transferred to new tasks. But if we use reinforcement learning, the only thing we need to do is like we design an appropriate reward function, and then we can use a very realistic simulator to train it. That actually I think is had a lower development cost. I think actually I find that many companies like autonomous driving, they are shifting from the traditional method to end-to-end method, because in this way they can save a lot of human costs. Like they don't need a very large team, very great engineers to write many code. That's my point. But actually it have a very great potential. However, it also has a long way to go, because the reliability issue, the bias issue should be solved before it comes to reality. Yeah.
Okay, thank you. So when you mentioned the end-to-end method, you would prefer the reinforcement learning method you just mentioned?
No, reinforcement learning is one way to replace the traditional method, but not necessarily reinforcement learning. Yes, in some tests we may we may easily obtain sufficient data, and then that's not necessarily reinforcement. That may be supervised learning or semi-supervised. Yeah.
Okay, I see. So actually, I want to ask for area robot, how would you like to design the reward for this task if you use the reinforcement learning method?
How to design
The
reward?
reward, yeah.
Actually, I think about designing the reward function of area robot is much. It's more like something to design the objective function in an optimal control problem formulation for the area robot, and that's in some aspects that I think reinforcement learning is a kind of optimal control, but without explicitly mathematical solving, but just automatically let the robot to collect data and get the reward and to train the network to get a lower loss. So I think basically to design a proper reward for our robot, there are some reward functions we may use. First off, firstly is safety of the flight. Actually, safety is a top concern of our robot because even when purpose of it gets some hit some obstacle, the entire robot will crash, and that's very dangerous for humans and other environments. So so safety is a top concern. And secondly, I think is a flight smoothness, and also that means how to design a proper reward to let the drone can fly agilely, can fly smoothly, and also it will get to the destination as fast as possible. So it's directly a reward related to the trajectory smoothness of the drones. And I think besides above this, I think also dynamical feasibility is also a concern because we have to let the planned the generated motion can be executable by the drones. So I think a proper reward function could be a combination of all this above. Okay.
Thank you, Professor Gao. We also got a question online. So the question is whether these foundation models can be applied in this kind of control scenarios with high frequency.
High frequency scenarios, can the foundation model be applied to high frequency scenarios? Professor Digo and Professor He.
So we got a question online. The question is whether foundation models can be applied in these control scenarios with high frequency.
So I have an opinion in this topic, and I feel like the usage of AI-driven models, even if it's foundation or if it's traditional supervised learning models, have a constraint when we go to applications. We work in our group also in shared control, navigation for wheelchairs and for mobile robots. And in this case, the concern is safety. And I feel like it's the same in aerial vehicles. At very high frequency, when the motion of the robot depends on the control policy that you're executing, if you don't have a full guarantee, or I would say a physics-based model that is closed loop, then you cannot deploy these systems. They are not realistically deployable. At least in Europe, it's highly regulated nowadays. Everything is AI-driven with the new EU policy for AI regulation. So I believe for once we can gather information, perhaps in our perception module. As you were explaining, we have these models always in our systems in robotics. Right? In the perception model, perhaps we are deploying partially a model, a foundation model. I'm not sure if it's going to be could be, you have sufficient power to execute. But at the end, the control policy is something that has more a traditional approach. You have a closed loop equation to navigate, to control the device, and to have, at the end, the most important part is the safety guarantees. Where does it come from? Where is your redundancy in your system? Where is your guarantee of the sensor and your output in your system? Here is where we have to be very careful. What we call end-to-end. This needs to be questioned when you develop something that you want to translate to a real robotic device. This end-to-end is not going to work in many applications because regulations don't allow it, because it's not safe. That's my opinion, at least.
Yeah, thank you all. Actually, I think this naturally leads to our second question. Although now these days there are still some limitations with foundation models, and I think as technology continues to advance, the foundation models will also drive the advancements in robotics. We can see that scientific progress should transition from research to industrialization to truly generate some societal value. And also this morning's plenary talk also encourages researchers to venture into entrepreneurship. So Professor Paez, I know you are the co-founder of two companies. One is about rehabilitation and the other is about wheelchair robotics. So in academic research, we typically pursue novel methods and state-of-the-art performance. But on the other hand, in industrialization, stability, safety, and also applicability has more concern, as you just mentioned. So how do we strike a balance between practicality and cutting-edge innovation?
Thank you for the question. So yeah, it's a very good question. It's something that as a researcher, we struggle to balance all the time. But I think for real relevant research, you have always to have this in mind. You are part of a society, and if you pose yourself questions, research questions, they need to have a value. Someone needs to care about it. Someone at the end needs this knowledge. So here is where, at least in my group, in our research, we try to balance. The research questions, they come out of an industrial need. And many of them out of a healthcare need. So you have a lot of questions about the human body, about how the rehabilitation process goes. And then out of there, we go to what are the questions that are relevant in research that are not solved yet. So there, in this, it becomes a cycle. It becomes a cycle between you have new questions in the research because of the industry is wanting to develop something new, faster, better. And now you have to strike the balance that where do you stop in research and then leave it to your industrial partner, or you have perhaps some people in your group that want to go more into the industrialization and go into more into the stability and to develop the product system. And then you have to stop your research there and then deliver this to them. So it becomes a continuous cycle of questions for research and then giving something for the industry to build up a product that has a value for society.
Yeah, I see. So it's not an easy task. Yeah. And Professor He, so I know you are interested in exploring embodied AI solutions for medical and healthcare applications. So in your research, safety and stability also has very top priority. So how do you find the balance between practicality and cutting edge innovation?
Well, that's true. Like for medical applications, whether it's the invasive type of medical intervention, or if say less interventional based intervention like imaging, reconstruction, or the rehabilitation, slightly bit more safer, but we still need high regulating the actions those technologies can achieve. We were discussing that of saying who's supposed to be the person or organization to regulating those development. Industrial is not regulated. Well, most of the case is regulated by the board themselves. In academia, at least in European countries, normally we have a good system of having ethics reviews or risk assessment of the implementations of the technologies. But there's also limitations because everything comes with a trade-off. If it's high regulated, there's a huge bureaucracy, especially in larger universities or old universities. Time goes quite slow, and it takes a long process to regulating those development. We find the challenges like the people who is in charge of this, of regulating these actions, are not necessarily the people who are on the front line of the research. So if there's a better system that can synergize the people who is making the regulation and the people who is making the research, so we could having a more healthy system to making it faster, but also well regulated. In terms of the the point of practical applications, I truly believe technology push and the larger impact should be driven or at least co-led by industries. So then it comes to the question of what is the role of a university. So essentially, university has two roles. One is education, one is research. For our PhD students, we not really want them to lead into a project. Their job is not to solve the problem. Their job is to learn how to identify the problem, finding the niche area they want to solve, and come up with several solutions, and also the systematic to validate this solution. We don't fight with industry for synergize or pushing further of a certain technology, but we would like to working with industry, or at least for some students who want to pushing further on the technology they really want to push, and they could either go further by their startup or innovations to generating the next level of technology in a more matured applied level. And at certain point, this will also benefiting the academia systems by providing more data in a more transparent, open source manners that can generate the next generation of ideas. Yeah.
Okay, thank you for sharing. So next for Professor Gao and Professor Zhou, I know you are from the same lab, and I know that a colleague from your lab co-founded a technology company called Benmo Keji. And also Professor Gao, I know that your student has also founded his own drone company, and the product is right now displayed at the NOKOV booth. So for an academic researcher to become an entrepreneur, what kind of characteristics should they hold, in your opinion?
Okay, that's a very good question. And actually, for me, I haven't been an entrepreneur up to now. But in my imagination, running a company is very, very different than running a research group. If you're running a company, you have to consider more every aspect of this company. You have to consider how to seek enough money, how to have good management, and of course you should have a very good leadership, and you have to have a very sharp vision to design, to seek opportunity of the market, and also for designing a good product and to get some impact from this market. And also, as you asked, some of my lab mates, Zhang Di, he's also in ICRA. I just saw him, and also my students who have run a startup company to make some drones. And I think it's quite challenging and quite interesting human life for them to choose this career path. And I think they may get different enjoyment other than choose the academic way. So I just want to say good luck to them. Okay.
Okay, thank you. Yeah, and Professor Zhou, I guess you also listened to this morning's plenary talk.
Yeah.
So also, is there any inspirations or any thoughts that you would like to share with us?
Yeah. Professor Gao just shared some difference between research and entrepreneurship. So maybe I can talk something I think that are similar between research and entrepreneurship. I think, for example, curiosity, creativity, and vision is very important. One must be very curious about new things and quickly apply new technology to solve some real world problem. That's very important. That's equally important in both research and running a company to solve some real world problem. And another thing, probably communication skill, because when we do research, we have to write paper to present our work and to show, to do presentation, to give talk to others, to promote our work. And then when we are in company, we also need to do very similar thing. We should promote our new technology to like investor. They are totally unfamiliar with your area, with your technology, but you must persuade them that you can use your technology to solve some problem. to take a big market. Yeah, and another thing probably adaptive to the change. When we do research, we see many startup work every day. The change is very rapid. So when we run a company, many competitors are doing the same thing, and they may propose something that are very competitive to yours, to ours. So we must keep changing, keep developing new technology so that we can be the first runner. Okay.
Yeah, thank you. And Professor Paez, so is there any difficulty or challenge you encountered when you founded the company and started your own business?
Well, yeah, of course, there are many challenges, especially starting with funding. Funding is quite a challenge. When you want to translate something that you have developed at the university, is a research project, it is really in the prototyping phase. You need to convince a lot of people. So to start at this point, you really should evaluate very carefully if what you are proposing, it is really bringing a benefit to someone. Is it really worth it? Is it really going to change the life of someone? Is really a product that is going to be useful? So those questions, as early as possible, you can pose them to yourself and to your team. It makes it a bit easier, because this is a big challenge that it comes out when you go and try to find investors and try to find other people to join your team, right? So this is one big challenge. The second one is the difference between research and industry. Now you are not driven anymore by curiosity, although you could be in the future, but in the first stages of a startup, you are really driven to industrialize your idea, to make it a product, right? So there you need to find a good team, right? I think constructing the team is the most challenging part, because you need this balance between people that have experience in developing products, people that have experience in going into marketing, people that have experience in interacting with many different stakeholders, customers, investors, your own team, and you need to balance this out, right? So it is quite an effort, but I believe it is worth it if you have the technology that you believe is going to change someone's life.
Yeah, thank you for sharing. Yeah, and Professor He, also after listening to today's plenary talk, so the speaker also mentions that these days the boundaries between academia and also the industry is becoming blurring, and sometimes people jumping around, they jump from academia to industry, and sometimes people may jump back from industry to academia. So is there any thoughts you would also like to share with us?
Well, I can only say from my experience in our system in Oxford, things are quite flexible. So many professors, especially in engineering, application focused. So many of them are encouraged to build a startup to increase the impact of their research as a good way to translate the academic findings. This is in particular for the case in biomedical research. Essentially, we have three partners in the game. We have academics as engineering for the technology developer. As researcher, we also have in clinics, who is essentially the person who the parties who are performing the task. And then we also have in most of the case a startup aiming for conducting the research, so scaling up matters. So normally people do is to building this ecosystem, translating the fundamental research from the lab to a clinical scale, clinical trials with the support of startups and the support from the clinics. I consider those, it's a change. We're at a different stage. Probably 20 years ago, things are different. You could wait in the lab and spending 5 years to doing fundamental research and wait for another 5 years to do the application and another 5 years to do real world implementation. But now with a huge, I would somehow competitive through the bigger technology firms and the fast development of computational powers, things happen much faster. So if the academia continue to be slow, stay in the comfort zone, then it can be a bit challenging. We're out of the story. Then probably the only solution is to rebuild this ecosystem to push a synergy from industrial applicational flows with the academic fundamental science. Yeah.
Thank you for sharing. Do you have any idea of founding your own company in the future?
Oh, that depends on the opportunities and applications.
Okay, thank you. So we also got some questions online. So we have one question. Do mathematical methods require less computation resources than deep learning reinforcement learning methods, Professor Gao?
Okay, thanks for the good question. And in my opinion, I think if you got a good and a clear mathematical formulation, a mathematical model of the robot of your problem, you may have a better understanding of this problem. So in this way, sometimes you may discover some better way to reduce the computation. For example, as we do the numerical optimization in our motion planning, we always have to derive the derivative of some cost function and of the constraints. And sometimes you can use some tool to do the derivative calculation. For example, the AD automatic derivative calculation method. In that way, you will you just input the formulation and you will output the derivative. You can use that, and also you can manually derive the derivative. And for the later one, if you manually derive the derivative, you may use your smartness. You may use your clever head to do some simplify and also to reduce. In this way, to reduce the calculation of this derivative. And in that way, you may require less computation in your motion planning problem. And which doesn't mean that which doesn't always hold, because sometimes you have this better result, and sometimes you may not have this simple way to reduce computation. But just as a conclusion, I mean, if you choose some mathematical way to model the problem, you may have a better understanding. And you may have the opportunity for you to design to some specific way, some rigorous way, even with more handcrafted work and more dirty hand work, just more work to get a better way to represent the problem. So in that way, you may reduce the computation. Okay.
Yeah, indeed. I think mathematical models has better explainability comparing with black box deep learning methods. So we also got. So apart from the task decomposition in the field of area robots, how would you think foundation models would work? Or what kind of functionality can it provide?
Actually, this question means that besides use the foundation model to decompose the task, whether we can use it to do something else. I see. Actually, in our research, we find that foundation model is actually very good for open vocabulary perception. For example, when we want to obtain the depth information, traditionally we may require many data to train the depth prediction model. But recently, there are some models like the depth anything. We can easily obtain the depth image from many previously unseen scenario. The zero thought capability is very good. That's so we can use it for many different environment to obtain the depth image. That's very important for every robot to understand the 3D information of its surrounding. And another thing is about semantic, because we can use like segment anything model to do open vocabulary segmentation. So we can create a semantic map of environment. That's also a very important field named semantic mapping. And given this environment model with semantic information, we can better do some downstream tasks like use the semantic to do task and motion planning. Yeah, so that's beside the task decomposition, we can use it for many perception tasks. That's my point.
Okay. Yeah, thank you for sharing. And now let's come to our interactive session. So for our audience present here and both online, if you have any questions, please raise your hand.
Hello. I'm a student, and my study is mainly on aero robots. And I know that humanoid robot is very hot now. And I want to know if there any point can combine aero robot with a manipulator.
You mean?
I see there are many aero robot guy here. So your question is about how to combine the manipulative capability with aero robot, right?
Yeah.
I think that always a good, a very hot research topic in our field, and we have seen many works and many papers and also products to combine manipulator beneath on the aero robot. But in this way, it's very difficult to control the aero robot because when you do some manipulation, when you command your robotic arm to grasp and to take something, it will have a force applied on the Zhou. So it's very difficult to compensate this force. It's this external force, and sometimes this force cannot be explicitly predicted or explicitly modeled. It can only be treated as noise or disturbances. So it imposes very difficult challenges on the whole body control. But I still think it's a good topic, and in the future we will see some flying robotic hand to take something to me and also do some different complicated tasks in industrial. I think it's a good topic. Okay.
So Professor Gao, so for like moving some objects or transferring some objects, comparing with the mobile robots on the ground, what kind of advantages do you think this area robots have?
Okay, I think the biggest advantage for our robot is that they can fly, right? So if you can fly, you can move from one point to another destination very fast and very direct, right? So if we can let the robot to take some object from one place to one place and with full autonomy, I think it's a very impressive pictures for me. And I always believe that this picture will come true very soon in the future because we have good advances in the planning, navigation, and also the manipulation, and also the foundation models, right? So I'm happy to see that they come true. Okay.
Yeah, thank you. So and now right now here I think we have a lot of PhD students here. They're pursuing their PhD, and at this stage they already have the ability to publish high quality papers in prestigious conferences like ICRA and IROS. But Professor Gao, I know you have published a science robotics paper, and it has been selected as the cover of the Science Robotics. Meanwhile, you have also published a lot of TRO papers. So could you please share with us some of your experiences when targeting these kind of prestigious journals?
Okay, I have two quick suggestions for students who want to target on this some so-called high level journals of robotics. The first suggestion is take care of every details of your work. Because for any robot, it's a complicated system, and it consists of many pieces of it, many modules. Consists of hardware, software, and consists of vision, manipulation, locomotion mechanism, etc. and you have to take care every details of your system. So only in that way you can build an elegant and great and impressive system. And based on this system, you can always get good publication. And the second suggestion is that pay attention to the way for presentation. I always believe that research is it must not only problem solving, it's also about solution presentation. So think of good ways to present your elegant solution, which consists of your paper writing, your figure drawing, and also the movie editing. So if you have a good paper, good figures, good movies, I think your work will have more impact in our society and also in the whole
Yeah, thank you very much, Professor Gao. So now, ladies and gentlemen, as we draw to a close, I would like to express my sincerest gratitude to our distinguished guests for their invaluable insights and perspectives shared today. I would also like to express my sincere appreciation to our audience, both here in person and those joining us remotely. Tomorrow at noon, at the same time and place, we will be hosting another STAR talk focusing on the theme of exploring emerging trend of human-machine integration in the context of foundation models. We look forward to your participation. So goodbye and see you tomorrow. Bye.